Assalamualaikum warahmatullahi wabarakatuh. Today we will present about a control system fundamental assignment, and the title is water pump house. My name is Muhammad Daniel bin Anang Shafil Anwar. I will present for introduction and others else. So for introduction, a position control system as well all know is essential to achieve the appreciated angular position of our system. This is accomplished by transforming a position input command into a position output response. For others, explain what the operation is all about. With the development of several satellites and radar systems, the importance of this control system with sufficient accuracy and precise position has increased in the industrial and communication area. Stability in the water pump house is achieved through a combination of well-designed infrastructure, proper equipment selection, reliable power supply, efficient control system, and diligent maintenance practice. Where the control is being used. As stated in the previous section, the system we use a closed-loop control system that is a mechanical or electrical device that regulates a system automatically to maintain a desired state or set point without the need for human intervention. It makes use for a sensor or feedback system. The transfer function defines the mathematic link between the input and the output is in a closed-loop system.
My name is Taib bin Taib Z. Okay, today I will explain about the application. This is the block diagram for the input, output, and feedback. And this is our model, the system to get the transfer function. To calculate peak time, settling time, and percent overshoot from the transfer function, we use the omega n squared to find the zeta. So from that formula, we can find our peak time and settling time. By using MATLAB, this is our graph for the system input. So as we can find from the graph that we get was stable, and this is an underdamped wave. So from this graph, we have two difference between calculation and the simulating. From the transfer function, the peak time we get is 0.36 second, while from MATLAB is 0.53 second, and our settling time from the transfer function is 2.014 second, and from MATLAB is 1.77 second, while our overshoot, our percent overshoot that from our transfer function is 48.9%, while our from MATLAB is 35.1%.
Bismillahirrahmanirrahim. My name is Muhammad Azim bin Sofyan. I will discuss about this assignment. In the context of the water pump house, running a simulation and obtaining result is crucial for assessing the performance and efficiency of the control system. By using a closed-loop control system, the water pump house can automatically regulate and maintain the desired water flow, pressure, or level without constant human intervention. To achieve accurate and reliable result in the simulation, determining appropriate value of the transfer function is essential The transfer function represents the mathematical relationship between the input and output of the system. In the case of a water pump house, it captures the dynamic of the water flow and pressure regulation. And for the analysis, in the context of a water pump house, a closed loop block diagram is commonly employed for control purpose. For a water pump house, the system can be modeled as a second order system due to its dynamic. Unlike a first order system, a second order system response is more complex and can be fully defined by a single time constant. Instead, it involves multiply parameter include the natural frequency, damping radio, and settling time. In analyzing and understanding the step response for a second order system in the water pump house is crucial for design and effective control strategy. By appropriately selecting the pole location, it is possible to optimize the system behavior, for instance, reducing overshoot and settling time can help maintain stable and efficiency water pressure regulation. Okay, for this assignment, we can conclude that based on the finding from the simulation and computation, it can be inferred that the water pump house operates as a second order system. The parameters such as percent overshoot, settling time, and peak time were determined from the simulation result, which closely match the calculation using the transfer function. The present overshoot represent the maximum deviation for the response from the desired set point and provide insight into the system transition behavior. The settling time indicate the time taken for the system response to reach the state within a certain range of the set point. The peak time represent the time taken for the system response to reach its peak value. For overall, the interference that the water pump house operate as a second order system and is undamped based on the present overshoot, settling time and peak time aligns with the simulation result. The transfer function calculation. This observation contribute to the better understanding of the system dynamic and aid in the refinement of the control strategy for optimal performance.